Hey everyone, welcome to PhosForUs, a podcast where we will be talking everything that is related to phosphorus. I'm Smitam and I have with me George. Hi George.
Hey Smitam, hi everyone. Welcome to PhosForUs. Smitam and I are part of Science and Technology for Phosphorus Sustainability Center, otherwise known as STEPS.
Yeah, and in STEPS, we are seeking answers connected to phosphorus sustainability that is turning out to be a wicked problem. We have experts from different fields, be it physical, life, social sciences, economic sciences, all are working together to address these problems. Okay, George, now the big question. Probably everyone listening to this podcast might be thinking, why phosphorus? Why do we even need a podcast on phosphorus?
Well, that's because phosphorus is among the few elements that have incredibly shaped the history of the whole Earth, of course. Phosphorus is everywhere, and a lot of times it plays a critical role. You'll find it in food, bones, and in your DNA, and it's been strongly influential in politics and on the battlegrounds. Not only that, you'll find a surprising amount of P in your pee. Did you know that phosphorus is so valuable that at one point we even used human skulls to get it?
Yeah, right. They brought the skeletons from the Battle of Waterloo for fertilizers. And you say P? Did you know that they needed over 5,000 liters of urine to synthesize phosphorus for the first time?
That was Henning Brand, wasn't it? The things people do for science. The whole story of phosphorus is so fascinating, and it's been crucial for humanity's growth. But modern science has shined a light on some of the problems surrounding it. And the complexities of the issues can be pretty mind-boggling when you really dive in. There's the issue of too much phosphorus and the issue of too little phosphorus. There's the issue of how do we distribute it equitably, and how do we ensure that our equity extends into the foreseeable future? How do we avoid losing it to algal growths that degrade the environment and pollute the atmosphere? There are so many problems.
Yeah, right. There are so many problems. But that's why there have been initiatives around the world to do something. And that's also why we are going to break it down in this podcast. In this episode, we are going to talk about phosphorus's past, present, and its future to give everyone a little background on why phosphorus is so valuable to us. And we were lucky enough to get a conversation with Dr. Phil Haggard and Dr. Jim Elser, two career-long phosphorus experts and the authors of the book Phosphorus Past and Future.
Dr. Phil Haggard is a professor at Lancaster University in the United Kingdoms. He studies phosphorus in soil for the improvement of food production and pollution reduction. And Jim Elser is a professor at Arizona State University and the director of the Sustainable Phosphorus Alliance. His recent work focuses on the emerging and complex problems of phosphorus sustainability in our food system. One of the questions that we asked Dr. Haggard and Dr. Elser is the question that we asked at the beginning of the episode. Why is phosphorus so important? We asked them for their thoughts, and here's what they said.
So phosphorus is essential for every living thing. It's even makes up the structure of the DNA of an organism. So you can't make your genes without phosphorus. So every living thing needs phosphorus basically for the storage and processing of genetic information. It's also central in the transactions of energy metabolism in this molecule called ATP, emphasis on the P. There's 3 phosphorus atoms in that molecule. So you can't transform energy or use energy without ATP. It's in the membranes around our cells. And for those of us who are vertebrates that have bones, it's a critical component of bone. There's more phosphorus by mass in bones than calcium. And everyone talks about calcium in bones. Well, you can't make bones without calcium. You can't make bones without phosphorus either. So every living thing needs phosphorus. And so it's completely at the central of so much biology that's out there.
Yeah, absolutely, Jim. And I'll just add to that if I can. I mean, so building on what Jim said, and then critically, what it does for us is it helps crops grow, and that's what's done as the world's population has grown over the centuries. You look back in history, it helps food production. It drives the food production on the earth and feeds us. And so, it's just part of why and how we survive on this planet. It's become really important to us, and and then of course we've started to accelerate its usage, and it has wider implications for pollution as well. But so it's just absolutely essential for our modern day living.
Right. There is no denial how essential phosphorus is for our modern day living. So we were curious to know how it all started. Where does all this phosphorus come from?
I wrote that part of the phosphorus book, so I guess I'll take that part. So, well, phosphorus is a chemical element. What does that mean? A chemical element is a particular configuration of protons, neutrons, and electrons. And phosphorus is the chemical element that happens to have 15 protons in its nucleus. So where did that come from? Well, it didn't always exist. If we go back in the history of the universe, elements were created by mysterious but scientifically well known, mysterious to us who aren't particle physicists, processes of nuclear of element formation. Starting with hydrogen and sort of smashing those nuclei together and adding up, really literally adding up the protons together, and then neutrons and electrons start spinning around them in this particular order, right? That's order is reflected in the periodic table. So how did we get phosphorus? We got phosphorus at the center of stars that were burning at a ridiculous temperature, I think 1,000,000 degrees Kelvin or some ridiculous temperature, and essentially fused the nuclei of oxygen atoms, which had previously been formed by similar processes. Oxygen has 8 protons in its nucleus, and you take 2 of those together and smash them together, you get phosphorus, but 8 plus 8 is 16, not 15. So somehow, by a process that a particle physicist can explain to you, one of those protons is thrown away in that process, and you end up with 15. So that's how you get phosphorus. You heat up the center of a star to 1,000,000 degrees Kelvin and form that nuclear combination. The big message takeaway from the fact that phosphorus is a chemical element is sort of a good news and bad news story. The good news is that phosphorus, being a chemical element, can't be destroyed. So we'll always have it. So therefore, it's always available to be used again. The bad news is phosphorus is a chemical element, which means we can't make any more. So all we have is what we've got.
And unfortunately, what we've got is also an inequitable distribution of phosphorus. Natural and geologic processes distributed phosphorus-rich sources to only a few locations around the globe. So while we have an abundance in some regions, many regions have a severe lack of the life-sustaining nutrient.
Globally, it'd be great if all the geological phosphorus was, uniformly distributed around the world, where everyone could have access to their own geological sources. It's not the way it works. Those sources were built up in the past, most of them by geological processes in ancient oceans that deposited phosphorus-rich sediments that were then geologically transformed into what we now call phosphate rock. And those deposits themselves had to be uplifted and into the continental surfaces, where they can be accessed economically by mining operations. So where are they? But there's some in Florida, and there's some in the Carolinas in the United States. There's some in Idaho, and those are where North American phosphorus is mined primarily. But globally, the largest phosphorus deposits we now know are in Morocco and Western Sahara, and those are likely going to provide much of the world's future phosphorus. And so what we're sort of dealing with right now is a geographically and geopolitically constrained source of phosphate rock for fertilizer production. And so that creates issues with respect to price and control and access. And luckily, all the places that have phosphorus fertilizer, including Morocco, are open to trade, and they trade and provide phosphate rock and processed fertilizer to markets that need it, like Europe and elsewhere. But on the other hand, all those receiving countries are sort of becomes vulnerable to price changes and other supply chain issues or, other sorts of disruptions that can take place.
And if you didn't know any better, you might think Dr. Elster was talking about gold. Phosphorus is really just that valuable, and it has been. Humans picked up on the value of phosphorus way back when, and maybe even before we started farming.
Yeah, so if you like, we got the phosphorus, and let's just think about how our agriculture started. So if you before it was even known that what phosphorus was, early settlers, early dwellers, they inadvertently realized the benefits of phosphorus by looking where they would defecate, where the animals defecated, and they would see and reflect on improved bits of crop performance, wherever they were herding their animals or living or growing their crops or whatever. So if you like, early agriculture, in a kind of accidental way, discovered the benefits of phosphorus by accident. It was in the late 1800s that Laws and Gilbert managed to improve the refinement of rock phosphate and improve the refinement of rock phosphate fertilizer with this kind of emergence of the refining of fertilizer and fertilizer use. And they set up a series of experiments to actually look at different trials which have been going for now, but which are still existing today, with different levels of phosphorus fertilizer added in those experiments since the 1800s.
For a little context, Laws and Gilbert were two scientists from Rothamsted Research in the southeast of England. The refinement process Phil mentioned is called beneficiation.
Right, George. This introduction of phosphorus to human species was just the start of things. Once we realized the value of phosphorus, there was no stopping us. We went to all lengths to get it. Like we mentioned at the beginning, from pea to dead bodies. We searched everything to find phosphorus and make fertilizers.
There's one really quite interesting macabre story, which is just worth mentioning, really, that there's a kind of famous macabre story around about the time, there's the Battle of Waterloo. And famously, there was the actual, the Battle of Waterloo, I understand that the bones from the dead from the Battle of Waterloo were used and pillaged, really, and brought back to Britain for turning into fertilizer. And what a story that is. That just shows, it's awful, isn't it? But it just shows the perceived value of the phosphorus in the bones. It really highlights that kind of part of the story.
And macabre is a great word. It's quite the story. And this level of desire for phosphorus was only in 1815, soon after the discovery of the benefits of chemical fertilizer. Thankfully, I'll say, with time, phosphorus became more readily available as more sources of phosphorus were discovered.
If you looked at the history of the Earth and plotted it in a long line, you just go to about midway through the last century, around about the 1940s and 1950s, and plotted the use of rock phosphate, you would suddenly see that all around the middle of that last century, there was a giant explosion, really, an immersion, an emergence of rock phosphate around the world. So round about midway through the last century, everyone got it. The world got it. They realized its value, and it just became distributed everywhere. And there's this giant, hump of phosphorus use emerged around about the midway through the last century.
Just as the new sources of phosphorus began to saturate the market, our problems with phosphorus also started. Perhaps one of the most visible of the problems is the pollution created by phosphorus.
Yeah, so the thing is, the issue is that what's happened is that humans have, in the last century or so, accelerated the phosphorus cycle for good reason. At some point in history, they cottoned on that if we mine the phosphorus, we distribute it around the world, we enhance crop production by putting the fertilizer, the rock phosphate fertilizer, on the soil, it helps all the crops grow. Great thing. But then the great thing that helps the crops grow, the problem is with that crop growth is it also helps plants grow in water that we don't necessarily want to grow. So it then leads on to kind of a pollution problem. And Jim's more of the expert of the aquatic plants and stuff. But the issue is that, what makes things grow on the terrestrial, the crops, we've accelerated the cycle. We're now seeing the fact that phosphorus kind of gets out of the system, it gets into the waterways, into the fresh waterways. It leads to plants that we don't want to grow to take over, and this idea of what's called eutrophication and the buildup of algae and plants that we don't want in the rivers and the lakes. And also there's concerns in the future about this effect also going downstream out into places like the Mississippi Delta, the Gulf of Mexico, the ocean margins as well. In the longer term, we've got to think very carefully about where it goes, into the seas of the world. So we kind of did something about 100 years ago or so. Human beings realized how cool it was for growing crops. We accelerated the cycle, and now we're kind of realizing, wow, it's really good for crops, but then it's also not so good for the water either.
Knowing that large amounts of the element is entering the environment, it raises the question, what pathways exist and what can we do to mitigate our losses?
Well, phosphorus is in the food system, and so its losses come from cropping, from agricultural fields, obviously. Also comes from animal husbandry and animal raising, livestock operations, manure, et cetera. It can leak a lot of phosphorus and nitrogen into the environment. Of course, we're part of the food system. So our waste itself is another place where phosphorus can be lost from to the environment when untreated sewage is discharged. Many parts of the world, we have advanced wastewater treatment that removes that phosphorus, and so that's a good thing. But lots of places that have untreated sewage still, or relatively poorly treated sewage entering the environment. So that's another place where we get it. Phosphate detergents are still available in some places. In many places in Europe and North America, they've been banned, but that can be actually a very important place where phosphorus can be lost to the environment. And so those are the main issues I think so the point sources of wastewater sewage outfalls are things we can better manage and have been successful in different places in doing that. The challenge we have right now is that most of the pollution, at least in North America, Europe, and elsewhere, those sort of environments is coming, China as well, coming from the non-point sources, and those are harder to manage, those diffuse pollution environments.
Yeah, for really, just to zoom in on some specific examples, for quite a lot of my research career, I spent a lot of time trying to help the UK government understand how we could stop phosphorus leaving agricultural land and go to water. And I can honestly say for the last 20 to 30 years, we've been trying to work on ways to help farmers, help land managers, help watershed managers prevent that happening. I mean, it's complex, it's really challenging. There's all sorts of processes and pathways. Different types of agriculture have different types of problems. Dairy farms have different problems to wheat farms. They're all really different. And of course, the amount of rainfall you get also makes it challenging too. And, without going into any great detail, there is a heck of a lot of thinking going on about how we can redesign farms and the landscape of farms to prevent, just in this one example, to stop runoff leaving farms and going into rivers.
Yeah, right. And while there has been a lot of effort in stopping the phosphorus coming out from farms, what we have also created somewhere with this rampant utilization of phosphorus is legacy phosphorus. In short, it's like the leftover phosphorus.
Well, yeah, legacy phosphorus is built up in soil over the period of the fertilizer use that Phil was talking about, right? And so even as fertilizer practices become more reasonable and more carefully managed, we've accumulated so much phosphorus in the landscape, both in agricultural soils and other places in the landscape, that it's still being lost out into the system and into rivers and waterways. So we're living with that, and we, will live with that for a while, even once we get our act together on phosphorus management. And that's, one of the things that is occurring to folks now.
One thing that the academically curious might question is, if legacy phosphorus is there, why can't we just use it?
Now, it's a great thought that we should be able to use it. The problem is it tends to, the legacy phosphorus tends to lock itself away in forms which aren't as easily available really as the kind of readily available fertilizer. So the plants can't get at it as easily as we would like. And I think we're kind of working on that. The scientists and the plant scientists are kind of trying to find funky ways to get at the legacy phosphorus and make better use of it. So that's a really good question. But we also need to remember the legacy is not just a kind of plant thing for the soil and for the agriculture, but there's also a kind of a legacy signal that we need to be aware of that might build up in watersheds and catchments as well. So it's kind of legacy in soil, but also legacy in catchments and watersheds as well. So there's this delay, this big delay that reflects what we've done.
And things get even more complicated when we factor in the climate change aspect.
One of the great challenges is that climate change isn't helping us. Changing in rainfall and runoff patterns is making it often worse, depending on where you are in the world. That's making it so we're chasing climate change because climate change is making it worse. But we've got to keep working at it, and it's going to keep us challenged for a long time.
I was going to amplify something Phil said there, which is that climate change is making phosphorus management more difficult by changing runoff patterns and increasing runoff and discharge. So that's one side of the climate change story. The other side of phosphorus and climate change is that phosphorus itself can drive climate change because of the effects that eutrophication and water quality degradation has on CO2 and methane emissions from inland waters. And there's been some pretty nice studies done on this that indicate that the emissions coming from fresh waters of methane and CO2 that are phosphorus driven are non-trivial. If we ignore them, we are going to be missing a big part of the story, and they are significant in magnitude compared to like transport emissions, for example. So if we do a better job with phosphorus management and keep it out of the water, we'll also be addressing climate change issues. And that's something that people like to try to keep things separate all the time and keep things compartmentalized, but that's not the way the world works, of course.
Dr. Haygarth and Dr. Elser also mention how inequitable distribution of phosphorus is further exacerbating the problem.
I guess there's another way of looking at perhaps a problem that we're not so obviously aware of, but we perhaps ought to be. And that is that, that we're, Jim and I here, we're speaking from a relatively privileged perspective from nations of the world which have, luxuriated in phosphorus supplies over recent decades, and our food production reflects that. So that's been, on the face of it, a good thing. And we're seeing the issues arising from that in our water and our pollution from that time. But the point is, one of the problems we also need to grapple with is that there are great swathes of the world, particularly, for example, parts of the continent of Africa, where actually, we still is an urgency to get phosphorus into the soils and into the agricultural system. So I guess one of the challenges for the future, as well as managing the surplus that we have in one part of the world, is also another of the problems is also still learning the lessons of those parts of the world that have used it. So we still have to get it to other parts of the world where it really still has to do its job in helping food production and in feeding people. So the world's not all at the same pace, and that we've got to manage that. We've got to manage that really carefully.
I'm sure by now we all will acknowledge that phosphorus management is very tricky. There are multiple levels of stakeholders involved, and taking them on board and developing a system to ensure phosphorus sustainability can be very, very challenging. But the question is, if phosphorus sustainability is even possible, how would it look? Was phosphorus ever sustainable?
When Jim and I, when we were writing our book, it dawned on us that actually, if you look back to hunter-gatherer times and early agricultural times, that was perfect sustainability, really. That there was a little bit going around. There was recycling of local manure, a concentrating of the phosphorus in animal dung from human dung that was going back onto the local crops. And if you like, it's just a circular system. The phosphorus that's going out goes back, it goes through the organisms, it goes through the food system, and it goes back on. And then, of course, as we started to redistribute that around the world, and there's a commercialization of phosphorus fertilizer moving into the last century, that imbalance seems to have emerged. And of course, it's all about, in my mind, sustainability is about getting the balance of the inputs and outputs in equilibrium. And of course, that's a very general statement, but that's where we need to get to. But I'm sure Jim has got some great insight in this area.
Well, the answer to that question depends, of course, on how you just decide is sustainable or not sustainable. I sort of think of a sustainable practice or approach as something that can last indefinitely, and that doesn't compromise the ability of future generations to have a good lifestyle. But so ultimately, we want to have practices that we can sustain that don't damage the ability of our descendants to have a high quality of life living in a just and equitable society. Yeah, so maybe we had that in the past, but whether or not though that's the quality of life we would like for ourselves now or our descendants is probably not the one we want. So how can we sustain our a lifestyle where people have long life expectancies? Now we have life expectancy has been increasing over time, where people are well fed, have good access to healthy, nutritious food, have good access to healthy ecosystems and biodiversity and safe drinking water. To me, that's the question, right? How do we keep that going? Because it seems like, our efforts to increase the per capita food supply that's out there, are associated with degradation of environment, loss of biodiversity, and loss of drinking water and water recreational activities and other things that water gives us. And so there's a lot of stuff wrapped up in why our current phosphorus system is not sustainable. It has to do with lifestyle choices of wealthy societies and individuals that like to eat a lot of meat in their diets, whether or not that can continue or not. But we like that. A lot of people like that, but it's damaging to the environment. How we decide what types of crops we grow, how many crops we grow for food production, how much we grow for biofuels, for example. People there's a lot of biofuels being grown with used as fertilizer. Maybe we don't need to do that so much. We have a food waste problem. So we grow a lot of food, produce a lot of food that doesn't get eaten. That requires fertilizer. So what are the societal processes that allow such food waste to continue or persist? All is wrapped up with sustainability issues. So diet choices, food supply and food waste is an issue. How we make food system level decisions about what's grown, what's not grown, what's subsidized, what's not subsidized are all things we need to wrap up. But ultimately, what we want is a society where people have ample choices of food, of healthy, nutritious food, and that is produced with processes that don't damage and compromise future environments for society.
And to take a very simple perspective on that, we need to be working towards a situation where we don't want phosphorus to be running into the oceans. That is not sustainable. We need to close the loop. We need to make the phosphorus that's being used in the food production has to go back in around the system. That is sustainable in the broadest sense. And then all the nuances that have been talking about, they're the challenges. But ultimately, we cannot tolerate it going down into the rivers and into the oceans in any longevity into the future. That is just not acceptable for future sustainability of our life and phosphorus use in the future.
But the question is how? How do we bring some sort of equilibrium to the phosphorus imbalance? How far are we from preventing the phosphorus from getting into our waters? And how do we retrieve the phosphorus that's already lost to us?
Well, there's two issues there, right? One is preventing the phosphorus from entering surface waters. And then there's the issue of recycling it, right, and bringing it back into the food system. Those are two different problems. Obviously, if you're doing the second one, you're also doing the first one. But you can do the first one without doing the second one. And that's mostly where we've made progress. We've made progress in wastewater treatment, for example. We have in many parts of the world. We have the technologies, abilities to efficiently remove phosphorus from wastewater discharge. There's great technologies available, and there's great success stories about how that's has played out. That phosphorus is not recycled, though. 99.9% of it is not recycled. There are technologies for recycling it, some of which are emerging right now. Most of that phosphorus that we trap in wastewater effluent in advanced wastewater treatment goes to the landfill. Some of it goes back on the land in the form of biosolids. There are issues related to biosolid reapplication on land, but a fair amount of that does go back. However, the phosphorus that passes through our bodies and therefore into wastewater treatment is only a small percentage of the phosphorus that's moving in the food system. A lot of it is lost at the agricultural field itself, tied up in soil, and that legacy phosphorus are leaching off into the environment in runoff. And that's a big part of the problem. A lot of it is lost at the animal production step. So we are growing a lot of meat, we're feeding a lot of very inefficient animals like cattle. Cattle convert maybe the 1/5 or 1/10 of the phosphorus they take into new biomass, and the rest goes out the other end. It ends up in manure. We don't do a very good job of recycling that manure because it's too heavy to move around and spread, because we've centralized animal production in very small areas and concentrated feeding operations, and therefore the manure is very hard to recycle. It's in a physical form that no one wants to deal with. And so we need to get that phosphorus back. There are technologies out there that are being developed. They aren't very far along. And the phosphorus that's being lost in animal production is not being recycled nearly as efficiently as it needs to be. So we're on the very beginning of this journey to a phosphorus recycling dominated food system, I'm afraid.
And now, we know we're the Phosphorus podcast, but we care about other nutrients too. Are there any parallels between actions being taken for phosphorus sustainability and recovery and other important nutrients?
Well, I would say that phosphorus is not added by itself in fertilizer, so it's almost always added with nitrogen as well as potassium. Nitrogen also can drive water quality degradation in inland waters and in coastal oceans. And so nitrogen management has a lot of the same similar problems. Nitrogen probably gets more attention than phosphorus for reasons I'm still trying to understand, but one of which might be the fact that N2O gas is a greenhouse gas. And so a fair bit of the greenhouse emission problem of agriculture comes from N2O emissions. And so there's a lot of pressure on nitrogen management to reduce greenhouse gas emissions. But anything we can do to improve fertilizer management to help farmers and move to agricultural systems that use fertilizer more efficiently in general will help with phosphorus management generally. It's not always the case. Phosphorus and nitrogen have to be managed specifically and for different types of crops. They behave somewhat differently in soil, but at the 10,000 foot level, things that we do to improve the nitrogen situation will also help the phosphorus situation. So, for example, how much meat is in our diet? As we begin to make progress there, we help with nitrogen sustainability. We also help with phosphorus sustainability. Same thing with food waste, right? The less food waste we have, the less nitrogen waste that we end up having, the less phosphorus waste we're having. So these problems are tied to each other pretty closely. And so, which is encouraging, right? Because we figure, okay, we'll get phosphorus improvement if the nitrogen people, are impactful, and likewise, the nitrogen management will improve if the phosphorus people are impactful in their approaches.
But how do we improve our nutrient management strategies? What would be more impactful? Like down at the farms with the application of fertilizer, or on the other side of the spectrum, like with lobbying, politics, and legislation?
Well, I think that in my mind as a researcher, I think the real priority for the future as a soil scientist is that we need to make up some progress with making plants more efficient in the ways that they use phosphorus that's inherent in the soil. Plants are really quite wasteful of soil phosphorus. The amount of available phosphorus that we measure in soil is typically, let's call it about 5% of the total. And yet there might be 20, 30, 40, 50% of the phosphorus in soil, which is just not doing anything. So I think the great, easy win priority area for research is to increase plant use efficiency and therefore reduce our reliance on the volumes of new fertilizer that we use.
Yeah, there's a lot to be done with things like precision agriculture. I think I just saw a new technology out there that was adding phosphorus fertilizer with the seed, right? Because phosphorus is very important early during seedling development and root formation. And so in this new technology, each seed gets a certain amount of phosphorus fertilizer with it, just a milliliter or two with it as it's being planted. Instead of filling the whole volume of the soil up with enough phosphorus that the seed will want or need, you just fill the area, right, that the seed is going to actually encounter during root development. And so then you could save a lot of fertilizer that way, apparently. So precision agriculture, better and more responsible fertilizer management on the farm will be great. On the policy side, it's a big farm policy in the United States is a gigantic political quagmire, I must say, looking at it from outside. As some people don't know, the Clean Water Act is not applied to agriculture. Agricultural practices are exempt from the Clean Water Act. So most of the nutrient management, or nearly all the nutrient management measures that are enacted or disseminated or encouraged are encouraged. It's all voluntary or incentivized in different parts of the farm bill or other measures that are implemented. So whether or not agriculture will ever come under subject to the Clean Water Act is something difficult to contemplate politically in the United States. It certainly would be something that would, because Clean Water Act did a good job in addressing things like out of the pipe pollution, like we had with wastewater coming from sewage and sewage outfalls and wastewater treatment. It did a really good job. However, it'd be very complicated if it were transferred to agriculture. But on the other hand, it can't be denied that agricultural practices are impacting water quality and impacting society as a whole. So that's on the political side of things.
Clearly, we have a long way to go before we can think of achieving global phosphorus sustainability. There are many hurdles to cross and many barriers to break. So, there might be a question, is there even any hope? Well, Jim and Phil believes there is hope. Hope that everything is going in the right direction, and sooner rather than later, we are going to overcome this phosphorus challenge.
Yeah, so I think the future of phosphorus. I mean, we've talked about the, if you like, the technical things, the many technical challenges and steps we need to go through to improve phosphorus sustainability. I mean, they are jobs to be done, innovations to be had, and in many respects we start to get on with those. But I think one of the things which is more subtle that we need to think about, and Jim and I thought about this when we were writing our book, is the right sort of leaders, the right sort of people to take this thing forward. So, it needs leadership. It needs people that can rally discussion, rally action across academia, across industry, and across all types of life, really, to take to really raise the issue and raise the debate. We thought about this when we were writing the book, and it does need that kind of that leadership. We, Jim, us, the community in the world tries to, have phosphorus summits and so on to help rally these debates and discussions. But I think there is still work to be done in the political space and perhaps at the global level to get this higher up the global agenda. So that's one of the real challenges, but there's hope. I think we're talking about it, and it's going in the right direction.
Well, I gain optimism somewhat from the complexity and interconnectedness of everything. And maybe we talked a little about this a little earlier. The problems are related to each other. And so to the extent that we solve some of the problems, we also on the side are solving some of the other problems. So, right, we can't solve the nitrogen problem without pretty much solving the phosphorus problem at the same time. And both of them are connected to climate change problem, which is being worked on quite earnestly, right? So to the extent that we're able to, move to a different way of operating in society to solve the challenges on us, we're going to, I think, solve the problems at the same time. And the solutions to one will help find solutions in the other. And so I think that that's a reason to be optimistic about things. There's a lot of good things that are happening right now. Population, so for example, is increasing, but it's slowing, right? So population of humans is starting to slow and is likely to reach its maximum in the next few decades. So as that's happening, people's well-being and standard of living is rising. Global poverty is declining, and that's a really good thing. As poverty declines, there's two things that happen. People's affluence goes up, which is good, which means things like their meat consumption and their total, environmental impact might also go up. But as people become better off, they are able, hopefully, to be able to afford more sustainable solutions than the things they might currently be doing in their country or region or in their lifestyles. And so a lot of the solutions we're talking about are, likely to be kind of expensive. But as society as a whole becomes more affluent, we can afford those more expensive things if we decide to invest in them. And so we have a lot of the solutions coming forward now. We kind of know how to fix things with respect to recycling manure, for example, recycling phosphorus from manure, recycling phosphorus from waste. We know how to do it. It's kind of expensive. We're going to have to decide to make those choices. But as, hopefully global well-being, as we become more affluent, we can afford to do that. And hopefully we'll make those wise choices because we'll be led by folks who are now coming on the scene, like Phil talked about, who are broad thinkers, who see the bigger picture, who know how things are connected and can communicate the benefits and costs and trade-offs and all of the interactions that come from moving away from the way we've been doing things and toward a system that will work better. And I think we can see what that looks like. Right now, it's starting to come into focus in the future. And for that reason, I feel optimistic about it. My career is, coming toward its conclusion. I've done my part, I hope. And now it's great to know that we can hand off the baton to a lot of really bright new thinkers and doers out there in the world.
Absolutely. We know a lot of folks who are working tirelessly to make an effort. And who knows? Maybe some of those doers are listening in right now. And that's the story of Phosphorus, or at least an overview of it. I really feel like I learned a lot from Jim and Phil.
Yes, I agree. I got a good taste of how complex the phosphorus problem is.
And we were lucky to have had a chance to meet with those two. We want to give a big thank you to Jim Elser and Phil Hagarth for their effort in the field of phosphorus and for their time with us on the Zoom call.
And thank you to our listeners for tuning into the first episode of Phosphorus. We also thank the National Science Foundation for funding our center, and the music that you heard is from pixabay.com. We hope that you were able to get acquainted with phosphorus and found value in something new today. This conversation is just the beginning, so if you're looking for more, keep an eye out for our upcoming episodes.
In the future, we'll be diving deeper into implications of phosphorus sustainability. A lot of the topics you heard in the past hour could be subjects of entire episodes. We'll hope you'll tune in, and with that, have a good one, and we'll catch you next time.